The notion of lifetime events is very simple. Basically, you are able to listen to certain events happening on the lifetime of components, and you can react to them somehow. So we're going to use this parent and child setup that we had previously. Let me just remind you what it was. So we had a parent which overrides to string and just outputs I am your father, and then we had the child which can refer to the parent and which can also output something if we want to. The key thing here is that the child wants to do property injection on the parent type using a mechanism of some kind, and in this case we're going to see a different mechanism for doing exactly that and also doing other things as well. So I'll make a builder as before, new container builder, like so, and then I'll register the parent type, register type parent. Nothing interesting to see here. We just register it. We're not going to customize it. But for the child, we're going to do a few additional things. So I'm going to say builder.register type child. But then what I want to do is I want to call on activating. So the on activating lambda that I'm going to provide is going to be raised before a component is used. Somebody makes the child, but before it's actually being used for something, we get to customize it somehow. So here, if I just open up the code completion, you can see it takes an I activating event args of child, which I'll just call A. And this is the object that we're going to use to customize the child that we've just created. So one of the obvious things that you might want to do here is obviously property injection, because parent has to be initialized for a given child, and this is a good place to do exactly that. So the way you would do it is you would say a dot instance, so instance refers to the child that we're customizing, dot parent equals, and then once again we're going to use that context that we've seen before. So we're going to say a dot context dot resolve parent. So you resolve the parent and you assign it to the appropriate property of the child, and then you can manipulate it somehow, or at least output it. That's what we're going to do next. So I'll make a scope, var scope equals, and then I'll just do builder.build begin lifetime scope, not even going to have a variable for the container. And here I'll say var child equals scope.resolve. I'll resolve a child first of all, and then I'll say var parent equals child.parent. And I'm actually going to output it. So console.writeLine, going to write line the parent. Okay, so let's see if this works. All right, so we just get the output for the parent. We might want to have a bit more diagnostic information, to be honest. And for this, I'm going to just add a few lines here and there. So at this point, I'm going to console.writeLine that it's the child activating. And in addition, if we go to the child itself, let's add something in the constructor. So let's make a constructor, and I'll write line child being created. So now we get a more complete picture as I execute this. As you can see, first of all, the child is being created, so the constructor gets called, then the child is activating, and finally you are able to use it and actually get the father in this case. Okay, so this is an example of the on-activating event. This is something that happens before a component is actually used. Now there is another event which is called on-activated. So the idea behind onActivated is that the component at this stage is fully constructed. So you've fully constructed the child, you've customized it to the way that you want it to appear, and now you want to do a few other things. Now, we're not going to do anything fancy in here. It's really up to you what you want to do. But what I want to do is I just want to output another line here. So I'll say child activated. So that's part number 2. So first of all, you have on activating, and then you have on activated. And of course, the final part, whenever you don't need the child anymore, is called on release. So let's do on release. And here we can once again have an action on the child. So the child here is the argument. And we can just write line that the child is about to be removed, like so. Okay, so that's the final bit. Let's now execute this and let's see all the steps one after another. So the child is being created, it's activating, it's activated. Then you have this I am your father, and then the child is about to be removed. So this is a sequence of steps, and you can customize each of these steps and do your own thing in each one of them. And obviously you can do this for any type that you're actually registering. Now there is a bit of a catch here that I want to show you, which is what happens if you are specifying register type as some interface or other, because it's rather unpleasant. And it's to do with the ability to actually replace the entire component, which is something that we haven't talked about yet. So let's go to the child class, and let's suppose I make a derived type called bad child. So this bad child is just going to have a different toString implementation, for example. So I'll override toString here, and I'll say something like I hate you, and the ordinary child will have a toString implementation saying hi there. And now, of course, it has to be virtual. I think it has to be, oh no, we're okay already. Okay, so each of these has its own implementation of toString. And now what we're going to do is we're going to replace the child with this bad child at the stage where you are actually constructing the whole thing. And it is one of the possibilities when you have the on activating. So let me comment this out first of all. So what you can do essentially is you can say a.replace instance, and you can take the entire instance that's being activated right now and you can replace it with something else entirely. So in this case, for example, I can make a new bad child, or I can resolve a bad child from the container if indeed I had registered it first of all. Okay, so let's first of all see how this goes. So I'm going to execute. In actual fact, the parent itself is null, so that's the empty part. But what is interesting is if we output the child as well as the parent. So let's output the child, and let's see what we get. And we say I hate you because we've actually created a bad child even though we're resolving an ordinary child. So this is one of the possibilities, but this possibility is sometimes a bit broken, and let me show you how. So if you have, let's say we have the console log, but we want to replace it with an SMS log, for example. So you might write something like the following. You might say builder.register type, register type of console log, like so. You register it as an ilog. There we go. That's the part that's going to cause the error. And then you say on activating, and whenever it's activating, you do the following. So you try to replace the instance. You say a.replace instance, and you replace the console log with, let's say, a new SMS log, which we've also created previously. I'll put the bogus phone number here like so. So this looks innocent enough. The assumption is that whenever you ask for an ilog instead of getting a console log, which might have been what was originally intended, you're going to get an SMS log instead. So then what would happen if we just said var log equals scope.resolve ilog, and then log.write testing. Now we're not even going to get to this stage. We're going to get an exception at replace instance. Let's actually execute this. All right, here is the exception. Now let me explain to you why this is going on. The problem is that the concrete type, which is console log, is actually being used for type resolution, and it's also being used by the activating event args. So this is not the best way to go about it. If you do want this kind of functionality, you have to do it in a kind of two-step fashion. So let me comment this out first of all. So first of all, what you would have to do is you would have to register console log as itself. So you would say builder.register type, and you would put in the console log here, and you would say as self. So you would just register the type as it is, and then of course if you want to register the ilog, you would say builder.register. Notice I'm using register and not register type. So here I register an ilog like so, and then whenever we specify the delegate, we say c.resolve console log. So we resolve the console log like so. But then of course here is the customization. So here we can say on activating, and we can say that we're going to take the arguments and we're going to replace the instance with a new SMS log with the number +1, 2, 3, 4, 5, 6. So this is actually going to work. Unlike the previous example, this is safer, and we can actually execute this. So I'm going to run this. And as you can see, the output here is using the SMS log. So we're sending an SMS with the log message. So hopefully this is a good illustration of the ways in which you can get these events. You can catch the events that are happening on the lifetime of a particular component, and then you can do something whenever the component is being activated, when it's activating, and then when it's finally cleaned up.